Hi viewers, Vanakkam, Vandanam, Namaskaram. You are watching Aha Namma channel. It's full and full education and entertainment. Watch the video carefully and learn it everything.
What does a sphere look like? The best example would be a football. It's round in shape and has no vertices. But how do we show it on paper? It will look something like this. This is the center of the sphere. Let's call it O. Another important thing we need to know about the sphere is that all points on the surface are equidistant from its center. Let us name these points A, B and C. It means OA, OB and OC will all be equal. And that distance is called the radius of the sphere. So if R is the radius of the sphere, OA will be equal to R. OB will be equal to R and even length OC will be equal to R. Is there any other way in which we can visualize a sphere? How about we take a semicircle on a plane? A semicircle is half a circle and this red line is its diameter. When this semicircle is revolved 360 degrees around the diameter, we get a sphere.
Where we first started with shape having edges, followed by some curved objects with curved edges. Now before we start with this session, here is a question for you which will introduce a new shape. Suppose we have an object which when placed on the ground, only a single point of it touches the ground. Further, this object can be easily rolled. So can you guess the object? Let me give you another hint. This type of object is also used in playing many games. Yes, you guessed it right. It is a ball. And we come across many such round-shaped objects in our daily life, like some fruits and vegetables, as well as the planets of our solar system, which are all round in shape. In other words, all these round-shaped objects are also called as spherical objects. Many people think that a sphere and a circle are one and the same, which is not correct. If you are given an exercise to draw a sphere on a paper, is it possible to draw it? It may look like a sphere because some artists draw it in such a way as to seem like a three-dimensional image. But in fact, anything drawn on paper cannot be three-dimensional. So it will be a circle only. Whereas a sphere is a three-dimensional object. Apart from these differences, they do share some similarities. Like in a circle, the distance of each and every point on the boundary from its center is always constant. That distance we know as the radius. Similar would be the case with a sphere. Only here, instead of a boundary, we call it as the curved surface. A sphere is quite different from other three-dimensional objects. So let's see what make it different. Friends, a sphere has no edges or vertices, therefore the entire surface is included as only one surface. Whereas other three-dimensional objects have edges, which further divide their entire surface into number of different surfaces. So like the other objects which we have already learned in our previous sessions, how can we calculate surface area of a sphere? Since it is round in shape with no edges, therefore it is a bit difficult to find its surface area. But we can make it easier to understand if we relate it with the curved or round-shaped objects. Let's do it. We all have seen cylinder, which is a curved object. And you know, when radius of a sphere and a cylinder are same, then that sphere could easily be fitted in the cylinder. And let the height of the cylinder equal to the height of the sphere, which is in fact the diameter of the sphere. then it is proved by the great mathematician Archimedes that the lateral surface area of the cylinder will be same as the surface area of the sphere. And we know that the lateral surface area of a cylinder is 2 pi RH, where r is the radius and h represents the height of the cylinder, which can also be replaced by the diameter of the sphere, and hence it can be written as 2 into radius. Thus, the surface area of a sphere is derived as 4 times pi r squared. Friends, we can also relate it with the circle and say that the surface area of a sphere is 4 times area of a circle. Right? Okay, so let's see what have we learned till now. We learned that a sphere is a three-dimensional object and the lateral surface area of a cylinder is equal to the surface area of a sphere, which is calculated by the formula 4 pi r squared, which we also say that 4 times area of a circle. So let's move a step ahead and try out an exercise. If we have to make a football with a diameter of 22 cm, then how much of a leather sheet will it need? Friends, we all have seen football, and the question is asking about the leather sheet, which is actually representing the surface of the sphere. So for finding out the requirement of leather sheet, we will find out the surface area of this football. And for that, we need only one parameter, that is the radius. And here, we have to make the football of diameter 22 cm. That means radius is 11 cm. So let's put the value of radius into the formula and we will get 1519.76 cm square. That means it will need 1519.76 cm square of leather sheet. So guys, this is how we make use of formula in different scenario. It is also used in many ways, which we are going to learn in our upcoming sessions. For now, we proceed further and see what else we can get from a sphere. For instance, if we cut a sphere into two equal parts, these two half-cut spheres are called hemispheres. So guys, if surface area of a sphere is 4 pi r squared, then what would be the surface area of a hemisphere? Well, we think that it would be half of the surface area of a sphere, that is 2 pi r squared, which is correct, but only in the case of a hollow hemisphere. For example, if we cut a tennis ball in half, which is hollow inside, here we will get circular edge but not the circular surface, whereas a solid hemisphere has a circular edge, which divides the surface into two surfaces. One would be the curved surface, which surface area will be 2 pi r squared, and the other would be the circular, which surface area will be pi r squared. So surface area of a solid hemisphere will be altogether 3 pi r squared. In other words, we can say that surface area of a hollow hemisphere is 2 pi r squared and surface area of a solid hemisphere is 3 pi r squared. But surface area of a sphere, whether it is hollow or solid, it will always be 4 pi r squared.
A half a sphere, or otherwise known as a hemisphere. Yes? So I'm going to tackle this in similar fashion that we did the pyramids and cones. I want to think of it as a third grade level. I'm not making a rigorous proof of this. We are just kind of doing a demonstration. We'll leave the proof for later. Okay, so what kind of object would I need to compare this with? This is a curved surface, so it'd be nice to keep a curved surface. So maybe I should have a cone. Yes, it's curved surface. It's got a circuit. It's got the same base. And I know what the volume is. Maybe I can, I don't know, but that's going to be hard. That's going to be a little difficult. Maybe, well, I can use the shape that I used with the cone. I use a cylinder. Now, how? It's nice that the base is the match, and they do match. Now, how tall should I make it? So if we want to try to eliminate as many variables as we can. We can choose our height. So we're going to make it a height that is convenient for us. We're going to make it a height that is the same, excuse me, as the diameter. See that? So, all right. So what do you think? More, greater than the cone, same, less than? I don't know. Let's go see. So we'll do it the same way. We will take and fill up our hemisphere once. Of course, more than once, of course. Right? Twice. More than twice. This time, oh, it has to be pi. That's right, because everything with a circle is pi, right? So it's going to be, this is not going to be enough, right? Let's see. And I'm not totally sure if you can see that, but it just goes exactly to the line. If I put my lid right on there, it will fill it up. Oh my goodness. I'm just so close from spewing out the top. So, yes, indeed, it is 3 of the hemispheres is 1 cylinder. We have hemispheres, and if we take 3 of those, we're going to get 1 cylinder, right? Now, the good thing is, we know that this radius here is equal to this radius. And how big was the height? Well, the diameter of this was going to be equal to the diameter of this. So that that means that it's 2 times the radius, right? All right, and the volume of this is nothing more than, I'll put another equals here, base times the height, right? So that's area of the base, pi r squared, times the height. And how big is the height? It's 2r. So that means this is pi under 2 r cubed, right? But that is 3 hemispheres, right? So if we want the volume of 1 hemisphere, that would be, I wrote this, it was 3 times, I'll write it, get my algebra correctly. 3 times the volume of 1 hemisphere is equal to 2 pi r cubed. Therefore, the volume of 1 hemisphere is equal to 2 pi r cubed divided by 3. That's 1 hemisphere. And if we want to find the whole sphere, that's 2 hemispheres. We just double that. So the volume of a sphere is equal to double that, or 4/3 pi r cubed. So those are your 2 important ones for today. Of course, if you know what the sphere is, cutting it in half gives you the hemisphere, and if you know what the hemisphere is, then you know what a sphere is. Fantastic. Oh, here you go.
Till I get up, time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays.
students, good morning to all. Chapter 13, surface area and volume. So last class I explained about surface area of a cube and cuboid. Now we see the example sums. Example number 1. Example 1. Mary wants to decorate her Christmas tree. She wants to place the tree on a wooden box covered with colored paper with a picture of Santa Claus on it. She must know the exact quantity of paper to buy for this purpose. If the box has length, breadth and height as 80 cm, 40 cm and 20 cm respectively, how many square sheet of paper of size 40 cm would she require? So because of Christmas, she need to place the Christmas tree in a wooden box. So here they given the measurement, length, breadth and height. So clearly you know that it should be a cuboidal box. It should be given in the figure 13.4. So next they have to take a square sheet. We need to find the number of square sheets she require. How we have to find out? So how much that wooden box covered? So we need to find out the total surface area of a cuboidal box, and it can be divided by area of a square sheet. So we have to divide this area. We get the number of sheet she required. So number of sheet she required, which is equal to total surface area of a cuboidal box, is divided by area of a square sheet. Now we move on to the solution. So in a solution they have to given length which is equal to 80 cm, breadth equal to 40 cm, height equal to 20 cm. By observing this three dimension, we know that this is a cuboidal box. So it is a cuboidal box. In this cuboidal box, we need to cover with the designing square sheet with the Santa Claus. So you see, this is a cuboidal box. We need to cover all the side. So we need to find out total surface area of a cuboidal box, and by covering with this square sheet, we need to find out number of square sheet required. So how we have to find out? We need to divide total surface area of cuboid box divided by area of a square sheet. In last class I discussed about formulas regarding total surface area, lateral surface area and volume. So total surface area of cuboid box, that means total surface area of a cuboid. So what is the formula? 2 into LB plus BH plus HL square units. So here L is length, B is breadth, H is height. Already they have to given the measurements. So directly I have to substitute it. So length into breadth 80 into 40 plus BH, breadth into height 40 into 20, and H into L, it should be height into length 20 into 80. So directly we have to multiply it. So all the value should be in centimeters. Centimeter into centimeter, it becomes centimeter square. So 8 4s are 32 and becomes 3200 centimeter square plus 800 centimeter square and 1600 centimeter square. This two we keep it as same, and we need to add these three values. 3200 plus 800, we get 4000. 4000 plus 1600, we get 5600. So we need to multiply that 5600 with the 2. So what the value we get? So 2 into 5600, we get 11200 centimeter square. So this 11200 centimeter square is the value, that means the area of cuboidal box. Next we need to find out the area of a square sheet. So area of a square sheet is nothing but area of a square. So that should be side into side. We have to written as a square square unit. What is the value of a? That should be the side 40 centimeter. So it can be written as 40 centimeter the whole square. 40 centimeter into 40 centimeter. So you have to multiple. You get the value. It should be 2 zeros. 4 4s are 16. You get the value 1600 centimeter square. So now we get the area, that means total area of a cuboidal box and area of a square sheet 1600. So we have to divide these two values and we get the value number of sheets she required. So number of sheet required, which is equal to, this is total surface area of a cuboidal box divided by area of a square sheet. So 11,200 centimeter square, which is equal divided by 1600 centimeter square. So now we simplify it. So we have to cancel the zeros. So 0 0 it will cancel and 0 0 it will cancel and we get 112 and centimeter square also will get 112 divided by 16. It can be divisible by 4. So 4 4s are 16, 1 4s are 4, 2 4s are 8, remaining 3, 8 4s are 32. Again we simplify it. 1 4 is 4, 7 4s are 28. So we get number of sheet required. So number of sheets required, which is equal to 7 sheets. So we have to find out the value. How many sheets we need? 7 sheets we need to cover the whole wooden box, cuboidal wooden box. Next we move on to example number 2. Example 2. Hamid has built a cubical water tank with lid for his house with each outer edge 1.5 meter long. He gets the outer surface of the tank excluding the base. So we now need to consider the base. So only we have a 5 face covered with the square tiles of 25 centimeter. Find how much he would spend for the tiles if the cost of the tiles is rupees 360 per dozen. Per dozen means 12 tiles, 360. We need to find out the total number of cost. We need to fix the tile. So here you have to see the last question also we have to find out number of sheet. Here we need to find number of tiles we need to fix. So we have to find out total surface area of a cubical tank without base divided by area of a square tiles. So we get number of tiles and we need to find the cost of one tile and multiple with total number of tiles means we get the total cost Hamid spent to build the tank with tiles. So here they have to given clearly it should be a cubical tank. So total surface area without basements it should be 5a square. Now we see the solution. Solution, they have to given edge of cubical tank which is equal to 1.5 meter. So edge of cubical tank. So cubical means it should be a cubical tank. Edge means this is. So all the sides should be a square face. So one of the side it should be 1.5 meter. So I need to convert this meter into centimeter. So 1.5 into 100 we get 150 centimeter. So we need to fix this cubical tank with the square tile. Square tile, the side is should be 25 centimeter. So side of a square tile which is equal to 25 centimeter. So you know that it should be a cubical tank. We have to fix all the side. It should be 4 lateral surface and 1 lid. And we no need to consider about the base. So we got 5 face. Okay, we have 5 face. So we need one tile. It should be a measurement 25 centimeter side. So how many tiles we need? So number of square tile. So in a previous example itself we know number of sheet. But we have to take total surface area of a cuboidal box. Here cubical tank. Total surface area of a cubical tank and area of a square tiles. So here excluding base they have to given. Excluding base means we have to remove the base. remove the base. That should be total surface area of cubical tank without base. Without base means remaining 5 face. Area of a square tiles. So one by one we have to see. Total surface area of a cubical tank without base means 5a square. So you know that total surface area of a cube is 6a square. So we need to exclude. We need to no need to take over the base. So you have to subtract 1a square. So we get 5a square. So 5 into 150 centimeter the whole square, 5 into 150 into 150. So this is the measurement of total surface area of a cubical tank. So we keep it safe. Finally we have to simplify it. Next we need to find out area of a square tile. Area of a square tiles, you know that area of a square, it should be a square which is equal to 25 centimeter the whole square. So 25 centimeter whole square can be written as 25 centimeter into 25 centimeter. So here this one also I keep it same. Finally we have to simplify it. So number of tiles required, which is equal to, so total surface area of a cuboidal tank, that should be 5 into 150 centimeter into 150 centimeter divided by area of a square tiles. So now we have to simplify it. By dividing fifth table, I have to simplify it. So we have to simplify 1 5s are 5, 5 5s are 25, again 5 5s are 25, 30 into 5, 150. So again we need to simplify 1 5s are 5, it should be 6 5s are 30, 6 5s are 30, again 1 5s are 5 and it becomes 30. So now you see in denominator there is no value. What is the remaining value? 6 centimeter into 30 centimeter. So 6 centimeter into 30 centimeter. So it's centimeter is also cancelled, divided by 1 centimeter into 1 centimeter. So centimeter cancel. So 1 into 1 you get. So 6 3s are 18. So 180 tiles. So how many tiles we required? Number of tiles required, which is equal to 180 tiles. So already they have to given cost of tiles per dozen, which is equal to 360. Cost of one tile, which is equal to 360 divided by tile. So cost of one tile, which is equal to rupees 30. So we need to find out cost of 180 tiles. Cost of 180 tiles. Cost of 180 tiles can be written as 180 into rupees 30. So here 0 0 you take this 2 0. 3 into 8, 8 3s are 24. So 4 remaining 2. 3 1s are 3 plus 2 5. So how much he need to spend? 5,400. So total cost. Total cost, which is equal to rupees 5,400. On this type of question, I have to attach the worksheet. You have to complete on the day itself. Thank you so much.
Thank you for watching நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை ட்ரைன் தட்டுங்க. பை.